How's it going? It's Dr. Schulman, and we've made it to the last part of numbers and operations, right? Isn't that wild? So the last part of numbers and operations, there's only thing, it's just number theory. In number theory, all we have are prime numbers, factors, multiples. Composite just means put together. So I'm gonna give you some definitions, but this one's gonna be super short. I hope you're excited. And yeah, let's get into it. So I'm sharing my screen. You want to follow along with how I do it, this is right here, Math for Teachers 1, numbers, number theory, and these are what they are. So when they say prime, when they say a prime number, guess what? It's not just a non-number. It basically is like the number like 7. The only factors are 1 and 7. It's like the number like 2, 1 times 2. 1 is not a prime number because it's 1 times 1. It has to be a 1 and a separate number. What's another number that's not prime? 9, because it's not just 1 times 9, it's also 3 times 3. 4 is not a prime number. Uh, Prime because it's 1 times 4 and 2 times 2. Another prime number, I don't know, like 31. 1 times 31, that's the only way to make it. Ta-da! So, what's another one that's common? 5. 1 times 5. What's the one that's not prime? 6, because it's 1 times 6 and 3 times 2. So that's prime versus not prime. Remember, 1 is not prime, if that helps. Now, when they say a composite number, that's things that aren't prime. So composite numbers is just like the number 6. 1 times 6 and 2 times 3. It has multiple factors that make it up. All right, now let's do a factor versus a multiple. So factors are just all the numbers that make it up. So if we have the factors, and usually they ask for the greatest common factor of two things, but if they ask for the factors of, I don't know, like 12 and 8, the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. They ask for the factors of 8, it's just 1 times 8 and 2 times 4. But I asked you for the greatest common factor. 4 is the highest number they match. That's different for multiples. Now, for multiples, usually you find what's called the least common multiple. Okay, that's the smallest number that they match. So let's say we have multiples. Let's say we have 20 and 30, right? So what are the multiples of 20? 20, 40, 60, 80, 100, 120. Ta-da! What are the multiples of 30? 30, 60, 90, 120. But they want the least, the smallest number that they match, and that is 60. So the least common multiple of 20 and 30 is 60. Now that's it. That's literally everything for 3A in like 5 seconds. But I'm going to show you all a bunch of ways to see the problems just for fun, and you can practice. And there's a nice little quiz on this, but let's jump into it. I'm going to go into my delta. Here's 3A. So when you see your 3A assessment, you'll see all these, but there's barely any of them. So I try to find some different ones, but they're really easy. So let's jump into this. So fill in the guided sentence below to explain how 10 by 10 relates to 5 by 10. So 10 is 2 times 5. So 10 times 10 is, I think it's 5 times more than 5 times 10. I'm pretty sure that this is. So this 5 times 10 is 50. And 10 times 10 is 100. I think this is what they want. No. Oh, 10 is 2 times 5. So, oh, okay, I see it. So that was my mistake because I put a 5 here. So 10 is 2 times 5. So 10 times 10 is 2 times that. Great question. I like the picture. Sorry, let's do a new problem. All right, so 30 is 10 times 3. So 30 times 2, 60 is 10 times, oh, so it's got to match. So 3 times 2 is 6, and 30 times 2 is 60. Cool. I like this problem. And I like the pictures too. The pictures are great. They didn't give us a fun picture this time, but that's okay. Let's do one more just for fun because they're short. 18 is 3 times 6. So 18 times 4 is 3 times, because if 18 is 3 times 6, then 18 is 4 is 3 times that value. 6 times 4 is 24. So 18 times 4 is, so we just have to think, we just have to multiply it by 3. What's 24 times 3? Don't be afraid to write on the side. There's your 2, carry the 1, 72. God. And there's our little picture. 6 times 4 is 24. And we have 3 24s, and we got it. What a great way to start. All right, what's the greatest common factor? Ooh, we have 3 of them. Nice. I think on your quiz, I put 3 of them. So we have 27, 45, and 20, 45, and 24. We want the GCF. So let's find all the factors. 1 times 27, 3 times 9. I'm pretty sure that's it. 45. And sometimes it's just 1, right? If there's no matches, just use the 1, because every number is divisible by 1. Okay. 1 times 45, 3 times 15, and 9 times 5. So if it's just these two, we'd have a 9. But 2 plus 4 is not equal to 9, so that doesn't work. But 2 plus 4. So if you want to cheat, you can use what's called numerology. 2 plus 7 is 9, and 3 goes in. 4 plus 5 is 9, and 3 goes in. And 2 plus 4 is 6, and 3 goes in. So I'm pretty sure it's going to be 3. 1 times 24, 2 times 12, and 3 times 8. 3 is the biggest number in all 3 groups that match. Don't be afraid to show your students the numerology rules. Ta-da! Cool. Let's do a prime factorization. Yeah, there's some of these on your test. So here's prime. All right. This is hard. And it's a huge number too. So we have 594. So you can do the tree. I don't really like the tree, but I'll do the tree. I'm assuming that's the way they want you to do it. So the first thing I'm going to do is I'm going to divide this by 2. 2 goes into 594. How many times? 2 goes into 5 twice. That's a 4. 2 goes into 19 9 times. That's 18. And 2 goes into 14 7 times. So that's 297. 2 plus 9 is 11. 11 plus 7 is 18. What goes into 18? A 3. We could also divide this by 9. So let's divide this by 9. Because I'm pretty sure 9 goes into 18 too. So let's try that. 9 goes into 297. 9 can't go into 2. 9 can go into 29 3 times. That's 27. 9 can go into 27 3 times. So that's 33. Well, we have 2 here. 9 is going to be 3 times 3. And 33 is going to be 3 times 11. So these are all of our factors. So we know it's 2 times 3 to the 1, 2, 3, 3 to the third. And you can't break 11. And that's what it is. So it's 2 times 3. And you always should put them in order. 3 to the third, because I have 3 3s, times 11. And this, you can check. If you want to show your students, check 2. Oh, I got to move my phone ahead. 2 times 3 times 3 times 3 times 11. We got it. So you could always check yourself. They did it. A 9 and a 66. Oh, because 5 plus 9 plus 4. This is how they did it. 5 plus 4 is 9. 9 plus 9 is 18. So they started by breaking it this way. But notice we still got the same answer doing it our way. Ta-da. Oh, God. Was this our way? Yeah, this was our way. Wild. Kind of. All right, let's do another one. Oh, we get to try some. Let's see how fast we can go. 39 and 42. I'm going 3. 22 and 24. I am going 2. 44 and 46. I'm going 2. 18 and 21. I'm going 3. 50 and 48. 8? No, 2. Okay, 46 and 38. Not this guy. What's 19 times? Is it really 19 times 3? Is that what it is? 19 times 3. Nope, not that guy. So it's 2. 35 and 24. What? Is it 1? Is 35 divisible by 4? I really don't think so. Yeah, I think it's just 1. Nice. 25 and 20, that's got to be a 5. 36 and 16. Is 36 divisible by 8? I don't think so. Is 36 divisible by 4? Yeah, it's 4. Wild. All right, 15 and 24. 12, nope. 1 plus 5 is 6. 2 plus 4 is 6. 3 goes into both. And the last one, 32 and 42. 16, not going to slice it. 6, not going to slice it. We're going to. We did it. All right, so I beat the best time that was on there, which makes me feel good. And just try your best. All right, let's do some least common multiples. So here we go. I have 5, 6, and 10. So here we go. 5, 10, 15, 20, 25, 30, 35, 40. You can go as high as you want, right? Or if you, I think that's the best way to do it. So we go 6, 12, 18, 24, 30, 36, 42. And then we got 10, 20, 30, 40, 50, 60. The first one that's a match, I believe it's 30. Yeah, it's 30. We did it. Cool. So try as many of these as you want until you feel confident, and then you can test yourself with this guy. Let's start the clock. 14 and 2 is 14. 15 and 5 is 15. 8 and 2 is 8. 12 and 8 is 24. 5 and 8. I'm going 40. 3 and 16. 16 is 24. No, it's not. Is it 48? I think it's 48. What's 48 divided by 16? I'm pretty sure it's 48. Nice. 9 and 4. 9, 18. Nope, we're going 36. 9 and 10. I think the first time they match is 90. 10 and 5 is 10. 2 and 20 is 20. And oh, we're already done. Nice. So try these. These are good ways to practice. Okay, let's see what this one has in store. So we're doing the division algorithm. All right, I'm not sure what the division algorithm is, but we'll find it. So we want to find both the greatest common factor and the least common multiple. This is usually the question that's on the licensure exam. It's usually they ask you for both because they're annoying. So let's do the greatest common factor first. 1 times 32, 2 times 16. Is that it? What's 32 divided by 4? I don't think it's even. Oh, it is. It's 8 and 4. Cool. All right, so then 36 is 1 times 36, 2 times 18, 3 times, is that 13? Nice. And 4 times 9. 4 is the greatest common factor, which is great. So we know the GCF is 4. Now, I think if we multiply these both by 4, we get their least common multiple. Let's find out. I think this is what they mean you can do. I've never tried this before, but let's try it. All right, 32. So 4 times 2 is 8. So 128. 4 times 6 is 4. All right. I don't know. I don't know the way to do it. I'd actually have to put them all up there. Oh, maybe it's the other one. Maybe it's 8 times one and 9 times the other. That might be the trick. 32 times 8. Oh, sorry, 32 times 9. So it's got to switch it. And 36 times 8. Let's see. Let's see if this works out for us. Why am I switching them? Because this is smaller. I'm just looking at what would be a pattern, and this is bigger. So I got to swap them. So 32 times 9. Oops. It's 288. And what's 36 times 8? Just because it says it's a division algorithm. Nice. We did it. That was really cool. So what does this algorithm mean? Whatever the GCF is, you can do the opposite ones and multiply them and get the answer. I just learned something. I love learning stuff. Magic. Really cool. I don't, my way is way simpler than this craziness, but who cares, right? Divide the prime numbers of both. Wild, 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 wild. All right, so you could do this method. I like mine better. The smaller one, the bigger the other. But if you like these Venn diagrams, have at it. Have at it. Cool. And then the least common multiple is you list all the primes. So 2 times 2 times 2 times 2 times 2 times 3 times 3. You list all the primes to get it. This is actually kind of cool. So you do prime factorization of one, prime factorization of the other, wherever they match. That's really cool. I'm gonna just show it. This is what they mean. I've never seen this before, and I love learning new stuff. So 36 is 2 times 16. This is 2 times 8. This is 2 times 4. And this is 2 times 2. So there's your first one. So they're telling you that 32 is 2, 2, 2, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it's 2 to the 5th. The other side is 36, which I would do is 2 times 18, 2 times 9, and 3 times 3. So the other side is going to be 2 times 2 times 3 times 3. So this is 2 squared times 3 squared. These are their prime factorizations. Where do they match? Four. So it's a matching of 4. I don't like that they're both in the same. I like that there's a 4 that matches on both sides. So that would be your GCF. I've never seen it done this way. And then if we multiply them all together, but this matches, so you only have to count once. 2 times 2 times 2 times 4 times 3 times 3 is 288. Still like my way better. I don't know why. But cool, we did it. And we learned something. All right, let's find the scale factor. Here's two triangles, 3, 6, 4, 8. We are doubling 3 times 6. And if you do this, 3 times 8 is 24, 6 times 4 is 24. That makes them similar. But either way, it's a scale factor of 2. Twice as big. Ta-da! 3 times what is 6? It's 2. Nice. Find the scale. Oh, we got a harder one. All right. So the triangle on the right is, but it's scaled down, right? So we know it's 50 times something gives us 11. So we divide by 50. It's 11 over 50. You can't simplify that. That's my scale factor. It is getting smaller. Nice. Oh, that's fun. Their way is really pretty. All right, let's do a scale factor area just for fun. All right. Rectangles H. And remember, it's similar to J. They know this is 21. We know this is 8.4. And we want the area of this one. So that's 168. So I think I like doing it this way. Area is, length times width, right? Or side times the other side, or base times height. As long as it forms a right angle, you're good. So we know it's going to be 168 equals 21 times x. You can go the other way, but I'd rather get the other side. let's divide this by 21. We know it goes in, so it should be nice and pretty. 168 divided by 21, we got 8. So basically, I'm just gonna do just like this, 8 over 21 equals x over 8.4 cross multiply 21x equals 8 times 8.4. And we're just going to divide this by 21. I'm doing extra steps because this is how I would teach it to a student. And we're going to divide this by 21. So this is 3.2. So all we have to do to get the area is multiply them. 3.2 times 8.4, 26.88. Now, if you just do 8, if you do it the other way, you should get the same thing. If you want to skip that step, that's fine. But I like doing it, all the steps for these. I think they're really easy to see. Their way is crazy. So they found the scale factor of 1 to get the missing side. I don't like that way at all. All right, let's do these couple left. Ooh, here we go. So these might seem a little harder, but it's still finding the greatest common factor, but now we have variables in the mix. So I always do the number first, and then I do the variable. So that's how I factor. So is there a number that 5 and 8 match, right? 5 is 1 times 5, and 8 is 1 times 8 and 2 times 4. It's just a 1. So we need to pull out a 1 from each. It's just assumed, so we don't really need it. So what matches on these guys? Well, this has an x and this is an x squared, so I can pull out an x. So 5 plus 8x. You could pretend there's a 1 there if you want, but we don't really need it. And then you could just check by multiplying it. This is how you can factor. 5x plus 8x squared. We did it. So factoring is just the opposite of distributing, and it's nothing crazy. 8, 5 plus 8x. Little geometry, little algebra, little. All right, let's do one more. Let's do a harder one. Level 2. Ooh, here we go. Now we get one that's actually has some going on. So the first thing I'm going to do, I'll look at 10 and 16 and see where they match. 1 times 10, 2 times 5, 1 times 10, 2 times 8, 4 times 4. 2 is the max. So we're going to pull out, not just a 2, we'll pull out the negative sign as well. So -2. So this one's going to be divided by -2, so that's a +5. This one's divided by a -2, so this is going to be a +8. I always do the numbers first, and then I mess with the letters. This matches x, there's 5 of them, so we just have to pull out 1x. That goes away, and then if we divide this, x to the 5th divided by x, it's literally like x to the 5th looks like this. 5 x's divided by x, you can cross one out, x to the 4th. Sorry about that. So we know our final answer is going to be -2x, 5 plus 8x to the 4th power. We did it. This is a negative quintic because it's to the 5th, just so you know. We never really have this first. So this is the way I would, if I were to write this, probably y equals -16x to the 5th minus 10x to the 4th. This is what's called a negative quintic. So it's going to look like that. Start high and low, and that's your picture. And it always has one less bump. 1, 2, 3, 4 bumps because it's to the 5th power. But this is your answer. -2x, 5 plus 8x, shift to the 4th. Oops. Not to the 40, to the 4th. Cool. And this is the last one. I hope you're excited. Oh, I wrote the problem wrong. I forgot the 4 there. If I had the 4 there, I would have it right. I have it right for mine. But I started with just the 1x, so let's just do one more for fun. And I won't do all that extra pieces. Oh, that's too easy. That's too easy. Here we go. This one's harder. Negative 100 x squared plus 30 x cubed. Where do these match? We can divide this by negative 10. All right, so let's divide it by negative 10 first. So that's going to be 10. And that's going to be a negative 3. What do these have in common? They have x squareds in common. So we're going to divide this by x squared, divide this by x squared. This is going to be x, and 3 minus 2 is 1. We did it. I just wrote the problem wrong the first time. This is a positive cubic, so this one looks like this. It's a positive x cubed graph. Negative 10x raised to the second power, parentheses, 10x plus, minus 3x. And we did it. We did the fancy factor. Wow. Mine's exactly the same. Mine's exactly the same. They didn't want a minus in the front. I wanted a minus in the front. I'm not going to argue with them. Oh, because there shouldn't be an x here. Because x squared over x squared goes away. Oh, well, I guess I got to do one more because I messed it up. Let's do a harder one. Harder. There we go. I won't mess it up this time. Negative 40x squared minus 5x cubed. The first thing I'm going to pull out is a negative 5. So this is going to be a positive 8. And then this is going to be a positive 1, but we don't need the 1. Then I'm going to pull out an x squared from both. So the greatest common factor is negative 5x squared. These two go away, so it's just going to be 8. 2 minuses make a plus 1, but we don't need the 1, so it's just going to be 8 plus x. And that time, there's no way I messed up. There's a lot of little parts here, so I can see why you might mess it up. I know this is a little beyond, but I'm always going to show you harder versions of all of these problems. Ta-da! Beautiful. Greatest common factor is negative 5 and x squared, and that's what's in the front. All right. This one's just variables. xy plus x cubed y. They both have an x and a y in common, so that's what we're pulling out. xy divided by xy. This is 1. There's nothing else, so you need the 1 as a placeholder. There's 3 of these. There's 1 of these. So 3 minus 1 is 2. And that's your final answer. But really mess with these. Have fun with them. Really try them. 1 plus x squared. And give it a shot. See how they go, you know. Really think your way through them. It's really good to understand how factoring really works for these factors. And finally, a multivariable. Here we go. We finally got a real one. 48 x cubed z to the 4th minus 44 x to the 6th y z cubed. There's a lot happening here. All right, always do the number first. I believe we can divide these both by 4. So let's divide it by 4, divide it by 4, and see if it works out. So 4 would make this one 12. That would make this one 11. So we're good. We have our numbers. So I have a 4, blank, 12, negative 11, blank. Cool. Now I have an x cubed. So let's do the x's. 3 and 6. So the most it could be is 3. Divided by 3, they all drop. Divided by 3, 6 minus 3 is 3. This is just a y, so we can't take it out. Now the z's in both. And we're going to take out a z to the 3rd, because that's the biggest one. All right, so z to the 3rd, 4 minus 3 is 1, so that's just the z. And z to the 3rd over z to the 3rd goes away. So there's your answer. There's your greatest common factor, 4x cubed, z cubed, 12z minus 11x cubed y. And that's your final answer. Notice I did the number, I did the first letter, did the second letter, then I did the third letter. It's just good to go in order so you never like get too tripped up. But this is the GCF here, 4x cubed. Then we got our z cubed. And then we have our first term, which is 12z. Then we're going to subtract 11, and then it's going to be x cubed z. So these are way harder than the ones that are on your quiz. And right after this, you do your first test. So good luck. Feel free if you want to try it. Where'd the first test come from? If you want to cheat a little bit, practice exams for the licensure. I used some CUDA software, and then I just made some up. So that's where the test questions come from. What? Where'd I mess up? 4x cubed, z cubed, 12z minus 11x cubed, z. Oh, I have it right here. There's the y. I just wrote the wrong letter at the end. Should I do one more just for fun? Sure, here we go. All right, 12 and 49. Is 49 divisible by 3? I think so. Pretty sure 3 is the big one. No, it's not. So the numbers don't get out. We just take out the letter. So it's just the letters. So this is x. Can I do this just in my head? So it's x z to the third. So it's going to be 12 x to the third the z falls away, plus 49. The x drops. We have a y because there's no other y, and 7 minus 3 is 4, z to the fourth. Sometimes it's easier for me to just visualize it without writing the whole thing out. Ta-da! It's 1249, their GCF is 1. Beautiful. All right. Well, I hope this video was useful. Good luck on your first test, and let me know if you have questions.